And welcome back to Cajun Coding, Code Friends and Code Family. This is St. Raz, and we are continuing on to learn Python 3 with Solo Learn in Mimu. We are just starting on string formatting. So far to combine strings and non-strings. You've converted the non-strings to strings and added them. Or it should say concatenation of the substrings. String formatting provides a more powerful way to embed non-strings within strings. String formatting uses a strings format method to substitute a number of arguments in the string. String formatting, so we've got nums, which is a list. Then we're going to create the variable MSG and assign to that numbers 0, 1, 2. Now this is a single string. Then we've got a comma. We're going to call the format. Is that a comma or a period? That might be a period actually. I think that is a period because we're calling the format method nums0, nums1, nums2, which relates to these three items in the nums list. Print MSG, and it prints numbers 4, 5, and 6. So you see this is a string, but we're calling the format method and invoking these addresses in the nums list so that it displays 4, 5, and 6 instead of 0, 1, and 2. Each argument of the format function is placed in the string at the corresponding position, which is determined using the curly braces. What is the result of this code? Print 010 format abra and cad. So what we would have is, let me see, 0 would be this, so it would be abra, then 1 would be the second item, cad, and then abracadabra. String formatting can also be done with named arguments. Example A, and then we've got X and Y. Dot, which we determined is a dot to invoke the format method, not a comma. Format X equals 5, Y equals 12. These are assignments, not comparisons. And then print A. A be X, which is 5, Y, which is 12. And apparently it puts the comma in there as well. There's a comma and a space. What is the result of this code? str equals, and then we've got C, B, and A. Then we are going to call the format method and assign 5 to A, 9 to B, 7 to C. So CBA would be reverse order, so 7, 9, 5, 7, 9, 5. And now we have some more useful functions. Python contains many useful built-in functions and methods to accomplish common tasks. Join joins a list of strings with another string as a separator. Replace replaces one substring in a string with another. Starts with and ends with. Determine if there's a substring at the beginning or end of a string, respectively. To change the case of a string, you can use lower and upper. The method split is the opposite of join, turning a string with a certain separator into a list. So for some examples here, so we've got join, spam eggs ham, and let me see, it would print spam comma space eggs comma space ham. Let me see, print This would be, this entire section here is one string rather than the display of a list of 3 strings. So let's see, print hello me, replace me, comma, world. The first argument is searching for the text to be replaced. The second argument is what to replace it with. So hello me, after invoking replace hello world. See, this is a sentence. Dot starts with this. Now this prints true. The starts with method returns a Boolean value. Either it starts with the argument that you're passing into it to check for, either it starts with that or it doesn't. So it's going to return true or false. Same thing with ends with. Obviously we're checking the end. Don't forget punctuation. There's a period there. This is a sentence upper, makes it all caps. If it's already all caps and you call the lower method, would be all lowercase. And split. The argument for split would be to pass in the delimiter that you're using to separate. And in this case, that is a comma and a space. It prints, you'll notice the brackets here. The brackets indicate that this string has been changed into a list of 3 strings: spam, eggs, and ham. Fill in the blanks to turn the string uppercase to go upper. It is upper. Numeric functions to find the maximum or minimum of some numbers or a list. You can use max or min. To find the distance of a number from 0, its absolute value, use ABS, short for absolute. To round a number to a certain number of decimal places, use round. To find the total of a list, use sum. And here are some examples. Min would return the lowest value, 0 in this case. Max would be 9. Absolute, abs, negative 99, that's its distance from 0, would be 99 with no sign, and that comes in handy. Abs 42, of course 42, and sum adds every list item together. In this case it would be 15. What is the result of this code? And our variable a is going to be assigned the value min, sum 1122, max, abs 32. So let me see. So sum, we're going to add these two together. So we've got 33, and then we've got abs 30, and then we've got 2. Now the absolute value of 30 is 30. The max of 30 and 2 is 30. So we've got 30 here and then 33 here. The minimum of those two would be 30. So print A would be 30. And I did not miss anything there. So list functions, often used in conditional statements. All and any take a list as an argument and return true if all or any respectively of their arguments evaluate to true and false otherwise. And that looks like that is an inclusive or and an and. So logically very similar to or and and. The function enumerate can be used to iterate through the values and indices of a list simultaneously. And here's an example. So here we've got the variable nums, and we're going to assign the list containing these elements. If all I is greater than 5 for I in nums. So this is an if, it's a conditional. This is the condition we're checking for, I is greater than 5, and we're specifying I is each value in nums, which is this list. And if that evaluates as true for every case as specified, then we would execute this code block all larger than 5. And as we can see, that is the case. If any I modulo 2 equals 0, which is another way of saying that it is even, for I in nums. So we're going to go through and check every single one as before. However, any means that if any of them evaluate as true, then the entire condition is true, and this code block would execute. And for v in enumerate nums, print v, and let me see, v in enumerate, wouldn't that just print all of them? I think it would. Yeah, that would just print all of them. So actually this first one is true, all larger than 5. This evaluates as true, so we print at least one is even. And then for v in enumerate nums, print v, and this just prints all of them, but it also prints the indices. We didn't specify the indices here. Indices are automatically assigned according to the position of the elements in the list when the list is defined. So, and what is the result of this code? Nums. Now we've got -1, 2, -3, 4, -5. If all abs I is less than 3 for I in nums, now this is going to be absolute value. So 1, 2, 3, well, this is 4. Actually 3 is not less than 3. 3 is equal to 3. So actually this would evaluate as false. It's not going to print 1. We do have an else, so it prints 2. And we have the text analyzer, our last section before we go to the module 5 quiz. Text analyzer. This is an example project showing a program that analyzes a sample file to find what percentage of the text each character occupies. This section shows how a file could be opened and read. So we've got our file name, and assigning to that input, enter a file name. So it's going to be accepting input, and we've got enter file name as the prompt for that. So with open file name as F. Remember with is going to automatically close our file when we're done with the code block underneath with. So we've got our file name named. We're opening that file. Text equals F read, and then print text. Okay. And the reason we have this is because we're prompting the user for the file name. So result, enter a file name, we put test.text, and then it prints out the contents of the file, which is apparently gibberish. If there was no such file, then it would throw an error. So we do know that that gibberish is actually the contents of the file. Fill in the blanks to read the contents of a file using the with statement. They shouldn't have said with. That makes it a little too easy. They should have said to use a statement, use a keyword that automatically closes the file. That would have been a bit more challenging. But with open file name as F, text equals F dot read. Don't forget your empty parentheses there. And it looks like we've got more text analyzer stuff. This part of the program rather, shows a function that counts how many times a character occurs in a string. So we're defining the count car, text, and then car count equals 0 for C in text if C is equal to car. Then we increment the count, so count plus equals 1. Then we return the count, and this is the for loop here. So this function takes as its arguments the text of the file and one character, returning the number of times that character appears in the text. So we've got the file name, input, enter file name, so we're prompting the user for the file name that we're going to open. And then we use the with as combination, with as, to open the file name. We're going to give it the name f, and then text equals f read, print count car text, and then r. And count car is what we defined up here. So we're calling that function from this line of code, and then we're passing in text, which it receives here, and then the character we're passing in R here, and then it's going to assign the car name, or assign that character to the car name, where it'll be addressed as car inside this function. So enter file name test.text, and then be 83 instances of that particular character. So why has the character counting code been put in a function? So it can be run multiple times. It will be faster. That's sort of true, but this is the real reason. The next part of the program finds what percentage of the text each character of the alphabet occupies. So what we've got here is for character, for car in, and then we've got the entire Latin alphabet here, and then PERC, which is obviously an abbreviation for percentage, equals 10 times, and then count car, passing in text in car, divided by the length of the text. Len is a built-in function, and we're going to be passing in text. Print, and then it would be we use the 0 inside the braces here, minus, and then 1 inside the braces, and then we use the percentage sign there. This is not modulo here. This is the percent symbol to be displayed via a string in this instance. Then of course we call the format method, passing in car, and then we have a comma to separate. Round is also a built-in function that we pass in the percent, and then we're going to round it to 2 places. So putting it all together and running the program, we've gone over each of these blocks of code already. And enter file name, test text, and then it will go and display what percentage of the text each of the letters represents. And the purpose of the round function, reduce the number of digits printed. I don't think it's actually going to save memory, because it will compute out to however many decimal places. It's just going to round that before it displays it. Rounding actually makes things less precise, so that's definitely not the answer. And here we are. It's the Module 5 quiz. And we're only about halfway through our usual lesson length, so we should be able to take a good bite out of the next module. Can you slice a tuple? I don't think you can slice a tuple. And then I could be wrong. Tuples apparently can be sliced. Actually, I should have thought about that a little harder. Tuples are immutable. You can't change the contents of a tuple. However, that doesn't mean you have to take the entire thing every time you need to examine part of it. So you can slice it, you can take a chunk out of it to use for whatever you need to, but you're not going to be changing the tuple itself. You're just taking a part of it to look at it or to use it for something. But the tuple in memory is going to consist of everything it was before. Which list slicing reverses the list numbers? Now remember, we've got our start. We have three parts: the start, the end, and the not the incrementer, in the step value. So you're going to take every one, or you're going to take every other one, or every third, or whatever. If that last one is a negative number, it's going to start from the right and go to the left. So this one would be the one that reverses the list numbers. What could be described as an immutable list, and we actually talked about this just a moment ago, the tuple is immutable. Even though you can take a chunk of it out to use for whatever purposes, whatever you're using that for, that's actually a copy of the tuple. The tuple itself is going to be unchanged. What is returned by functions that don't have a return statement? Not unusual in many languages, and sometimes called void or null. In Python, it's referred to as none. What is the result of this code? Nums, and then we have several values there, and now we're going to print, and we have a few functions nested within things. So we work from the inside out. So we're going to take the max of the min of these two, which is nums, and we'll get to that in a moment. We've got absolute value of 42, which is 42. Nums, we've got our starting and our ending. Now we see our colon here, we have no start, so it's assumed that we're going to be starting at the beginning of the is this a tuple? This is a tuple. So we're going to start at the beginning and go up to 2. So this is 0, 1. This is 2, but we're not using 2. We don't include that one. So it's 55 and 44. So we've got 55 and 44 in here. Take the minimum. The minimum is 44. And then we take the max of 44 and positive 42, which is 44. So it would print, let's see if I got lost in there somewhere. 44, nope, that's correct. Yeah, good old deeply nested things for our exercise.
Our online store is our business. How are you backing up your data? And the more you look at that, the more you want an app like this to take care of it for you.
The close thing, there we go. All right, and our next section is functional programming. Let me see. We've got regular expressions, Pythonicness, I'm not sure what that is. Object-oriented programming. So now we're doing functional programming. And this is the Greek letter lambda, if I'm not mistaken. And lambdas are a feature of several programming languages. Check that out. That's going to be the second section here. Functional programming is a style of programming that, as the name suggests, is based around functions. A key part of functional programming is higher order functions. We've seen this idea briefly in the previous lessons on functions as objects. Higher order functions take other functions as arguments or return them as results. So just as we've seen in some of our exercises, those exercises, those questions where we have parentheses inside parentheses inside parentheses, and we're taking the max of the min of the absolute value and things like that, those are actually functions that are returning values that are then then are passed in as arguments for other functions. And so it's not just a helpful way to look at those to solve them in an exercise, but it's actually what's happening inside the interpreter when you nest things like that. So here's an example where we're defining the apply twice function, and then we're passing in arguments. In the first argument, we're going to call func. Apparently, we're going to get that value from another function. And then the second one we'll call arg. In return, let me see, func passing in arg, and the result of that is going to be passed in as the argument for another function call. And then we've got define here the add5 function that we're going to pass x into. Then we're going to return x plus 5, which makes sense since we named the function add5. So here we go, we're going to print apply twice, add 5, and then we're going to pass in 10. And what happens when you add 5 to 10 2 times? Well, you get 20. The function apply twice takes another function as its argument and calls it twice inside its body. What is the output of this code? Define test func arg, return func arg, define mult x, return x times x, and now we're going to print test mult. And where are we passing in? We're passing in 2. Okay, so we're going to call mult. We're going to call test. We're going to pass in mult 2. So we're actually going to call mult first. 2. It's going to return 2 times 2. That's 4. So we're going to call test and pass in 4. So test func arg. So 4. We're going to call function return function arg. So it's 4. It's recursive. What is that? So it's going to be 16. Let me go ahead and do. It is going to be 16. Okay, because it's nesting the functions within functions there, and it is kind of easy to get lost in those. So sometimes you have to sometimes you would use like a scratch piece of paper and a pen or something. You can also open just a notepad or something like that and keep track of things as you step through the functions there. In programming in real life, you might be putting statements in there in the function that can return information to the console or to the display, indicating what stage in the process you're in or what the current value is of a variable that you're going to be performing further computations on, and that can be very useful in debugging. Pure functions. Functional programming seeks to use pure functions. Pure functions have no side effects and return a value that depends only on their arguments. This is how functions in math work. For example, the cosine x will, for the same value of x, always return the same result. Below are examples of pure and impure functions. So we're defining our pure function here, x, y. We're going to assign temp as x plus 2 times y, and then return temp divided by 2 times x plus y. This is a pure function because if you pass in the same value of x and y, you'll get back the same answer every time. Impure function here, sum list equals, and this is an empty list. And then we're defining the impure function, and it's going to be, we're going to pass in an argument, sum list dot append arg, and this is considered impure because you can pass in this arg, but depending on what some list has in it, you may not end up with the same thing. In fact, if you run this twice and you pass in the same argument each time, the second time you're adding to a list that you've already added something to. So as you repeat this, even if you're putting in the same argument, your sum list is going to get longer and longer. So this would be an impure function. Doesn't mean it's necessarily wrong. We try to stick with pure functions, but when you're manipulating files and such, obviously the file that you're working with is going to change. So, and is this a pure function? Def func x, y equals x, and this is x squared with the double stars. Z equals x plus y, and then return z. This actually kind of depends, because we're passing in x, but we're also using these variables y and z. Well, actually, we're not using z. We're just defining inside the function. We're returning that. Actually, what about y? Well, y is just x squared, so we're defining y inside the function too. So now I'm going to completely reverse what I thought first. We've got these variables x, y and z. Where are these coming from? If they're different, then it would not be a pure function, or might not be a pure function. But we're really not coming from somewhere else. We're defining these and assigning value to them within the function. So if you put the same number x into this function, you'll always get the same number out. So this actually is a pure function. Using pure functions has both advantages and disadvantages. Pure functions are easier to reason about and test, more efficient. Once the function has been evaluated for an input, the result can be stored and referred to the next time the function of that input is needed, reducing the number of times a function is called. And this is called memoization, and they're easier to run in parallel. And see, the main disadvantage of using only pure functions is that they majorly complicate the otherwise simple task of I/O, input-output. Since this appears to inherently require side effects, they can also be more difficult to write in some situations. Is majorly actually grammatically correct? I'm not sure about that. I've used that word, but I am majorly conflicted about whether that's actual good grammar. Which of these is not an advantage of using pure functions? They're easier to run in parallel. We actually just heard that. They're easier to write. They're easier to analyze. They are easier to analyze. Sometimes they can be harder to write, though. So and now lambdas. Brush up on your Greek alphabet. If I make reference to the Latin alphabet that we used earlier, if you are reading all this stuff along with me in English, that's the Latin alphabet. We got that from the Romans, who used a different alphabet from the ancient Greeks, which uses alpha, beta, gamma, delta, epsilon, and lambda is in there as well. So creating function normally using def assigns it to a variable automatically. This is different from the creation of other objects such as strings and integers, which can be created on the fly without assigning them to a variable. The same is possible with functions, provided they are created using lambda syntax. Functions created this way are known as anonymous. This approach is most commonly used when passing a simple function as an argument to another function. The syntax is shown in the next example and consists of the lambda keyword followed by a list of arguments, a colon, and the expression to evaluate and return. Okay, and so what does that mean? So we're going to define my func we're going to pass f and arg, and we're going to return f and passing in arg. And my function lambda, which is a keyword, x, and then we have a colon, 2 times x, and then 5 here. And it doesn't say what the output's going to be, but that's the definition of the function and using the lambda expression. Lambda functions get their name from lambda calculus, which is a model of computation invented by Alonzo Church. What are anonymous functions called? Well, there's lambdas. Lambda functions aren't as powerful as named functions. They can only do things that require a single expression, usually equivalent to a single line of code. So we've got define polynomial x, return x cubed, that's squared, x squared plus 5 times x plus 4. Does that look familiar? So we've got x squared, and then we've got an x with a coefficient plus an integer. Well, that's like a linear, like a quadratic equation, isn't it? Polynomial. So polynomial, and we're going to pass in -4, and that would come out, see, -4, so that would be 16 plus, is it 16? Yeah, 16 plus, actually it would be, with -4, that would be -20. So 16 minus 20 would be -4 plus 4, so that's 0. Let me see, and see lambda, print lambda x, and we're going to naming x there, and then x we're going to assign the value, oh I'm sorry, we're taking in x is our input, and this is the expression x squared plus 5 times x plus 4, and then at the end here is the x that we're passing into the lambda expression, which is -4. This is the same thing up here, so this resolves again to 0. Why would they use 0? That seems weird. In the code above, we created an anonymous function on the fly and called it with an argument, which is what I just explained. Let's play around with this stuff. Let me see. Let's try it yourself. Okay. And what would happen if we had 5 here? You know, it's only going to change the top one. The bottom one's still going to be 0, see? So we got 54. So 5 squared is 25 plus 5 times, well, 5 times is 25. So 25 is 50 plus 4, 54. There we go. Or let's do 10. Or negative, let's do -10. There we go. -10. Should have done it down here. How is it still 54? Really? So you see -10. So that's 100 plus, it would be -50. So 100 minus 50 is 50 plus 4. And it's a 54. That's so weird that it did that. Let's do a +3 down here. Now we're changing the bottom one here, because the bottom one is the lambda. So we've got 3 squares. 3 times 3 is 9 plus 15. 9 and 15 is, let's see, 24 plus 4 is 28. Okay. And if I can get out of here, that's nothing worth saving. We're not going to be bragging about that. Alright, on to the next lesson here. Fill in the blanks, or the next question rather. Fill in the blanks to create a lambda function that returns the square of its argument and call it for the number 8. So we're going to return, so we've got, lambda x, and then we use the colon. It returns the square of its argument, so it times itself is the square, and we're going to call it for the number 8. So we put 8 right there, and there you have it. Lambda functions can be assigned to variables and used like normal functions. So here we have the variable double is the name of the variable, and then we use the assignment operator, keyword lambda. X is what we're passing in, x times 2. What are we passing in? Oh, okay, here it is. It's x plus 2. Now here we're going to print double, and then here's where we pass in, inside these parentheses, is where we pass in the value to the lambda expression. Notice that we've got more than one set of parentheses here. We've got the set of parentheses where we're passing in the value to the lambda. Then we've got another set of parentheses because we're printing, and then we're calling double, which is the lambda expression. And of course, 7 times 2 is 14, not 7 times itself. There's rarely a good reason to do this. It's usually better to define a function with def, define, instead. It's kind of the whole point of lambdas is they're just in line. You just work with them right there. So, why wouldn't you just put the lambda expression in the place where you would put the variable name to which you assigned the lambda expression? So, but do know that it is possible to assign a lambda to a variable name. And the result of this code, triple equals lambda x colon x times 3. Makes sense. Add equals lambda x xy. Why? Because we got two things that we're adding together. Why? Because I gotta. Okay, so lambda x comma y, then your colon that indicates the start of your lambda expression, which is x plus y, because we're adding. Okay, and what are we going to print out here? Okay, we're going to print add triple 3 4. Okay, so we look at add here. Add has two things in it. It's got 4, and then we're going to be calling triple inside the add. So triple 3. 3 times 3 is 9, and 9 plus 4 is 13. There we are. Okay, and it looks like we're 43 minutes in. I like to keep the lessons about 45 minutes long, and if we were at the quiz already, I might go ahead and push through, but we've got several sections here before we reach that quiz. So we're going to go ahead and wrap this video up. We're going to be starting with map and filter for the next time. We're going to like maps and filters. Lots of utility there. A lot of these functions can be made with what we've already learned, but it would take kind of a lot of work to use to create basically a feature that's already built into the language, and you're going to be seeing that a lot with maps and filters. So we could do this the long way, just with the things we've learned with variables, with lambdas, with conditionals, loops, for loops, while loops, things like that. But once you know how to do that, you would be doing it at the same time every time. Well, that's not dry. Dry is don't repeat yourself. That would be wet. Write everything twice, and that's kind of the antithesis of what we do with programming. We invented computers to do stuff over and over again that's boring and that we already understand, and then we don't want to have to go through the long way. So, and you're going to be seeing that a lot demonstrated with maps and filters. So thanks so much for joining us this time with Cajun Coding. I appreciate it. As always, like, subscribe, recommend the channel. Any questions, comments, requests are always appreciated. I'll see you all next time. Bye-bye.